Okay guys, so we're going to get into naming and writing ionic and covalent structures with this unit. So this is all going to be test tube material for my college LIT class. So anyways, starting off with our periodic table, we labeled all this information last time earlier in the semester, but we're going to go through and just review. So this has a +1 charge, this column has a +2 charge, +3. These are plus or minus 4. They usually don't involve any sort of ionic bonding. -3, -2, -1, and 0. So we're talking about the whole column. Now we have things called transition metals. So transition metals are called transition metals because they can have multiple charges, okay? So what you need to go through is you need to go through and highlight or circle the elements that I've highlighted on my periodic table. That way, whenever we go to start doing this stuff and your first element is one of the ones that are highlighted, you pump your brakes for just a second and decide what charge it's going to have. And I'm going to show you how to do that in just a second. I printed out I posted an ion chart that looks like this. So we're going to be using this throughout the course of this test material. So these are all different ions we're going to be using. What I'm going to say is you're going to get more familiar with these as you go and start doing a lot more problems. So just don't freak out when you're doing it. So if you see, like if you look down here, there's a dash right here, dash. Those are -1 charges, -2, -1, -3, you know, so you have to look at them kind of closely, especially when I'm videoing, you know, so be careful. Some of them have similar names, so you need to make sure that you pay attention to what you're looking at, okay? So we're going to go and we're going to start by looking at our chemical composition and formula notes, okay? So the oxidation number or valence number is the number of electrons an element gains, loses, or shares when combining with other elements. We know that a positive charge means that it lost electrons, and a negative charge means that it gained electrons, okay? Positive ions are called cations, and negative charges are called anions, just so if you see those words. Okay, so if the compound starts with a metal, okay, and so metals are to the left of the zigzag line, we write the symbol for the element with the positive charge first. The positive charge always goes first. Then we write our charges. Now, it's important to know that if charges are equal and opposite, we do not crisscross, okay? And we're going to go through a lot of example problems. We don't crisscross a 1. It's always understood to be there. And we write a formula containing polyatomic ion. If you're crisscrossing a number to that ion, so in this case we have magnesium hydroxide, we're going to crisscross a 2 down here. We have to keep that hydroxide ion together, okay? We've already talked about transition metals. Now, and then there's a different set of rules for if it's a covalent compound or it starts with a non-metal, okay? We don't crisscross on this. We use prefixes. Your prefixes are given right here. Mono, di, tri, tetra, penta, hexa, hepta, octa, nano, deca. Okay, so we're going to go through some example problems, and we got 20 of them, okay? And then hopefully we get the hang of that by going through these example problems, and we'll start there, okay? So when we're writing ionic and covalent compound structures, we're going to need our periodic table and our ion chart. Okay, so I'll try and have this in front like this. Okay. So, calcium. Symbol for calcium is Ca. Calcium has a +2 charge because it's in the second column. Okay. So, write +2 charge. Oxygen is oxide when it becomes an ion. It has a -2 charge because it is in group 6A. Okay, this column has a -2 charge. Now, we notice that these are equal and opposite charges. Okay, so there's no need to crisscross anything, so this is just CaO. And that's it. That's all we're doing. Symbol for silver is Ag. Okay? Ag from our periodic table or our ion chart, we already said it has a +1 charge. Okay? It always has a +1 charge, even though it's a transition metal. Bromide is Br with a -1 charge. Those are equal and opposite charges, so we don't crisscross. So this is AgBr. Okay? Okay, ammonium nitrate, fertilizer. Okay, so ammonium, the ion ammonium isn't on our periodic table. It's what we call a polyatomic ion. So a polyatomic ion means that there's more than one element in the ion. Okay, so ammonium is NH4 with a +1 charge. Nitrate. Okay, so we're going to go down here. And nitrate is right here. It's NO3 with a -1 charge. Okay, so these are equal and opposites, so we don't crisscross and we don't use parentheses. Okay. Now we'll start getting into other problems where we're going to have to crisscross, okay? So symbol for copper is Cu. Now, copper is one of those transition metals. See, it's one of the ones we highlighted, okay? So it's going to have multiple charges. This Roman numeral 2 tells us what the charge is, so it's a +2 charge, okay? Hydroxide, go into our ion chart. So our ion chart, OH with a -1 charge, and it's a polyatomic ion. Now, these are not equal and opposite charges, so we're going to have to do something called crisscrossing. So we take the number 2 and we bring it down here. We take the 1 and bring it over here. So we get Cu parentheses OH2. This is a polyatomic ion and I'm crisscrossing to it. So I have to keep it in parentheses. When we crisscross a 1, we don't write the 1. It's understood to be there. Okay, next one. Symbol for iron is Fe. It's one of those transition metals that we highlighted right here. So it has a +3 charge in this case. Sulfate is SO4 with a -2 charge. We get that from our ion chart. So sulfate's right here. So we're going to crisscross. We're going to bring the 3 over here and the 2 over here. So this becomes Fe2 SO4 parentheses 3. Okay, so we have to keep polyatomic ions together. Okay, so a polyatomic ion is any sort of ion that has more than one element with it. Nickel, symbol for nickel is Ni with a +2 charge. Chlorate is ClO3 with a -1 charge. These are not equal and opposites, so we're going to have to crisscross. Now, when we go to crisscross, we don't write the 1, and we're crisscrossing something other than a 1 to a polyatomic ion, so we have to use parentheses. Okay, chlorate, let's see where chlorate is. Chlorate is right here. Okay, so it's just going to take you getting familiar to where your ions are, and it'll go a little bit smoother. You just got to do a lot of problems, I promise. Calcium, symbol for calcium is Ca. It has a +2 charge because it's in group 2. Chromate is CrO4 with a -2 charge. Okay, so chromate is right here. Right there. Okay, with a -2 charge. They're equal and opposite charges, so we don't crisscross anything. Okay, and if it's not on the ion chart, say like we're doing like lithium, or say we know it's in group 1, well, you just go with what's on the periodic table. That tells you what it's always going to be. But for the most part, your ions will be on your ion chart. Sodium hydrogen sulfate. So the symbol for sodium is Na. It has a +1 charge because it's in group 1. Hydrogen sulfate, okay, or bisulfate is another name for it. Okay, hydrogen sulfate is HSO4 with a -1 charge. So that's an ion that we keep together. They're equal and opposite charges, so we don't crisscross. So it's NaHSO4. Like that. Copper 2 chloride, the symbol for copper, or copper 1 chloride, symbol for copper is Cu. In this case, the Roman numeral tells you it's a +1 charge. Chloride is Cl with a -1 charge. They're equal and opposite charges, so we don't crisscross. Okay. Iron 2 oxide, symbol for iron is Fe, has a +2 charge. Oxide is O with a -2 charge. Okay, those are equal and opposite charges, so there's no need to crisscross. Okay. Now let's go on to the back. Okay, copper 2 chloride. Symbol for copper is Cu with a +2 charge. Chloride is Cl with a -1 charge. They are not equal and opposite, so we have to crisscross. So we bring the 2 down here, the 1 over here, so it becomes CuCl2. Okay, symbol for lead is Pb with a +2 charge. Acetate is C2H3O2. Okay, we get that from our chart. So acetate is right here. Okay, so has a -1 charge. So those are not equal and opposite, so we have to crisscross. Okay, so we bring the 2 down here. We have to keep the polyatomic ion together. Magnesium hydrogen carbonate. Charge of magnesium is Mg with a +2 charge. Okay, we get that from our periodic table because in group 2, hydrogen carbonate or bicarbonate is HCO3. And it has a -1 charge. Okay, they're not equal and opposite, so we have to crisscross. So this becomes MgHCO3 2. Okay, so we have to keep our polyatomic ions together. Symbol for potassium is K. K is in group 1, so it has a +1 charge. Sulfite, okay, is SO3 with a -2 charge. Okay, we're getting that from our ion chart. Sulfite, okay, is SO3 with a -2. Okay, they're not equal and opposite, so we have to crisscross. Okay, symbol for sodium is Na with a +1 charge. Phosphate is PO4 with a -3 charge. They're not equal and opposite, so we crisscross. Okay, so we get Na3PO4, like that. Now make sure that these are written as subscripts below, okay? Don't make them up here. They're not superscripts. They're not in line with that. They're below. Symbol for potassium is K. It has a +1 charge. Sulfide, okay? If it ends in IDE, it's on the periodic table. So sulfide is -2 charge. We're going to crisscross. We get K2S. Arsenic pentoxide. Okay, so we're going to get into some of these other ones, and then we're going to go through the practice problems that are on the front. Okay, so arsenic. Arsenic is AS. It's to the right of the zigzag line. So if your first element starts to the right of the zigzag line, we're going to use those non-metal rules that were in section 2 of our notes using the prefixes. Okay, so the symbol for arsenic is AS. We don't write charges on covalent compounds or things that start with nonmetals. Pent means 5, so we have 5 oxygens, and that's it. Okay, magnesium bromide. Symbol for magnesium is Mg. It has a +2 charge. Bromide is Br with a -1 charge. They're not equal and opposite, so we have to crisscross. Okay, so we get MgBr2, like that. And sodium, symbol for sodium is Na, the +1 charge. Carbonate is CO3 with a -2 charge. They're not equal and opposite, so we have to crisscross. Remember, when we crisscross ones, we don't write them. There's no need for parentheses here because I'm crisscrossing a 1 down there. You only put parentheses around a polyatomic ion whenever you're crisscrossing a number other than 1. Okay, last one, and then we're going to go to a couple more examples, and then we'll be done with this video. So, diphosphorus heptoxide. Okay, key words here are, key things in this problem are the prefixes di and hept. So that's a giveaway that we're probably going to be using our non-metal rules. So I'm going to check my first element, phosphorus, is to the right of the zigzag line. So I have to use prefixes, and I don't write charges. Phosphorus is P, prefix for di is 2, okay? Oxide is O, and hept is 7, okay? So it's P2O7. Now we didn't get a lot of practice problems on these, so I want to go to these example problems down here, and let's do those. Okay, so all of these elements start to the right. All of the first ones start to the right of the zigzag line. So phosphorus, nitrogen, and carbon, okay? So they're all gonna follow these rules. So the prefix for di is 2, so this is P2. Pent, like a pentagon, is 5, so O5, P2O5. Trinitrogen dichloride. Tri means 3, so it's N3. Di is 2, so Cl2. And then carbon dioxide. So the symbol for carbon is C. Di means 2 oxygens. Now, some of you are going to go prefix crazy whenever we start naming these compounds. We're writing structures right now. So it's important to note that we don't use prefixes when the first element is a metal. We only use it whenever they're non-metals. Okay, so don't go prefix crazy. Don't go parentheses crazy. Your stuff needs to match exactly how I wrote it. There's only one right answer, and it's my answer, okay, unless I messed up, which happens occasionally. So what you need to do from here is you need to complete this worksheet. Writing ionic and covalent structures, worksheet number 1. And what we'll do is we'll come back and we will go through these questions just like we did on the last one. And there's also another worksheet called Writing Chemical Formulas Practice number 2, Extra Practice. And I suggest that all of you do this one also, okay? It won't take you that long. So if you have any questions, feel free to reach out, and hopefully this was helpful. Thanks.